Hello everyone, how it's going? So here one geek guy in a new video. Has been some time since I don't release a new video because I was working in this project that I am going to show you here. So basically, if you want to keep yourself updated with the latest news and so on, you can subscribe to my channel, give it a like, and also you can visit my Instagram because I used to post more often there, so feel free. So today we are here with a project that I have been working on for some time already. So in my channel I have been posting a series of videos that I will let you hear for a motor controller, right? But I wanted to do something a bit more specific, let's say. So basically this board that you can see here is what I have been working. I have in my workshop the milling machine, for example, and in my case I have a stepper motor like this one you can see here, right? And I always wanted to control it in a way that I can see, for example, the feed rate and so on. And also I have another kind of stepper motors that I want to control, for example for a cooling system that I am preparing as well, that it has a stepper motor. And all of these needs, let's say, this is results from them. So basically what this is a motor controller board, as you can see here the name, right? It's really basic. So the idea behind this is that it's a really affordable PCB, but versatile. All this project is open source, so in the description you will find everything. So not only the files, but also I have written a manual, really detailed manual regarding how to connect everything and so on. So please feel free to go there, and you will see it also the source code for Arduino, because I already developed a source code that still needs to be polished, but it is working. And also the PCB design, right? So everything is there. So now we are going into the PCB itself, or this module that you can see here. And basically what we have here is LCD 16 by 2 lines or characters. It's a small one but versatile. That the position is this one. Here we see a small PCB that we are going to see in detail later, that basically it has an encoder and a switch that it is latched in 2 positions. And the function of this encoder basically is to select everything within the menus, speeds and so on. It has also a push button, and the function of this switch basically is to go to one direction and go to the other direction. I decided to go in this distribution because, as you see, it's really compact, so it's not big and can be easily integrated in a housing or whatever. We don't need that much space. And what it is more important is what we see here in the back. So basically this board is based in Arduino NANO, which makes it really easy if you want to develop a software, because in the manual you will find all the connections and all the possibilities. So even if you want to start from scratch, you will see where each pin on the Arduino is connected, so you will be able to develop your own software to control the stepper motor driver. And because it's cheap. So as I said, still I don't have a fixed price for this board, but I can tell you that it will be not so expensive, more or less like the controllers that you find in AliExpress. So we have this integration here. Important thing, it's the logo, the name, it's Motor Controller Nano, and you can always go with your mobile phone if you have the PCB, scan this QR code, and you will have access to the repository to see the manual and whatever. The function of this PCB, or it's that it can control a motor driver. Okay, it cannot control directly the motor because it will require more space and so on. So I decided to make it a bit more flexible in a way that it has an input between 9 volts and 24 volts. Right, I would recommend you to use 12 or 24. It depends. These are the 2 more common voltages, and you can see, as you can see here is the main power supply. It has an LED that it will indicate that it is power, and here we see that it is the voltage input 9 to 24, and it has reverse polarity protection in case you miss the polarity. Here we have 3 outputs. One is pull, the other one is N, and the other one is dir. So basically it's pulls, enable and direction for the motor stepper driver. And the good point of this one is that it's really flexible, right? Because we have access to the two, internally it has a transistor, and we have access to the emitter and collector in a way that we can have different configurations that I will explain you in the next video, or you can already go to the manual where it is everything described. We have here this jumper that basically it's for program the Arduino. So to program the Arduino we need to remove this jumper. And we have these 3 selectors here that what they do is select the output for the motor driver in a way that if we are using 12 volts or 24 volts. So right now it's connected to 12 volts, but if we move it to the other position, it will be connected to the 24 volts. What this means? That if we are inputting here 12 volts, we can select 12 volts and we don't need any series resistor outside because it's incorporated. And the same way with 24, right? We can configure it and it will provide the current that the motor driver needs. We have here another connector with 3 positions that basically this is for external switch. As you can see here, we have this switch here, 3 position, but we can put external switch like this one in a way that, yeah, if we have industrial machines, it will be more suitable. So as you can see, one position and the other. So this is possible connecting it in these 3 pins that I said. It is in the manual, but I will do a video specifically for this. And we have these 2 connections that they have, or that they are for end stops, but that basically what we need is a normally closed end stop, as you can see here, in a way that we can put end stop for the both sides, right, R and left. And one more feature that this PCB has is one auxiliary input, as you can see here, and one auxiliary output. For what we can use this one? Well, for example, if we can add a tachometer, we could use it the auxiliary input, or if we can control another signal, we could use the auxiliary output. So basically, it gives us a bit more flexibility in order to control another signals. We have here, as you can see, a small potentiometer in order to control the LCD contrast. And I will say that basically that's quite everything. So as you can see, it's really a small and compact PCB. We have as well the Arduino that we can program any moment. And I will show you now another PCB that it has no the Arduino, because behind the Arduino we have some stuff. This spacer that you can see here is from PCBWay. It's 3D printed. It's really easy to print with them. Basically, the only thing we need to do is to upload the STL file, and they will take care about how to print it. For sure, we need to select the materials, but that's all. Anyway, we are going to do another video entering a bit more in details on this process. And this PCB that you see here, you can extract it, and basically it's really easy to connect because you see this point here, and in the PCB you see this another point, right? And here said match the point. So basically we go here, we match the point, and we have everything connected, right? So let's put this a bit aside, and I will show you how it is the PCB without the Arduino. So basically this is what we have. Similar, but in this case the Arduino is outside. We can use Arduino with a USB-C connector or USB mini, it's not a problem, it doesn't matter. And basically what we have here is the controller for the LCD. So the important thing that the LCD that you buy, okay, or yeah, if I send it to you, does not need the I2C transformer, right, or converter, because it's directly incorporated in the main PCB. And here we see the 2 ends of, well, and here we see 2 jumpers that basically what they do is enable and disable the end stops. So in case we want to have an end stop, basically we need to remove the jumper as it is here, and in case we don't want to have an end stop, basically the only thing we need to do is to put the jumper, and that's all. So as you can see, as said, it's really compact PCB. This is the main PCB. It has here some namings as well in order to guide you how to connect everything. So basically we have the end stop, the switch, the motor controller signals with the emitter and collector, also the voltage selector for the driver signals, the jumper for Arduino programming, voltage input. The PCB is from PCBWay. As said, I am really pleased with it. I will show you how to order it in the next video, that it will talk about a bit more in detail how the PCB is for the people that you are more interested. Also here we have the jumpers for the end stops and auxiliary input and auxiliary out. So as you can see, everything is on the PCB, so you will not even need to go to the manual. With the PCB you have everything, but as said, you can always go here and you will be able to access to the manual. And a bit more information regarding to this. So basically I will proceed to assembly everything, because as said, it's really easy. So we have the main PCB, we have the LCD, and the only thing we need to do is to assemble this one, right? For this one we need spacers of 11 millimeters for M3 screws, as you can see here. If you cannot 3D print this part, that I said, you can always request it to PCBWay. You can use 11 millimeter spacer with M3 screws, as it is here. Basically, the other thing we need to do is to connect the Arduino, like this one. So we check if we want to use the end stops. So basically, since I am not going to use it for this one, the jumpers, they are there. So basically we need to insert the Arduino like this one, right? And this will be working. I recommend you to program the Arduino before inserting it. If not, what you need to do is to remove this jumper, okay, program the Arduino and put it again. And basically that's almost everything. The only thing we need to do right now is to take this PCB, that right now I am checking different lengths of encoders, and inserted it here like this, right? So you see, and basically we could use an op in order to be able to control the encoder and also to control the switch. So basically this is the assembly, and if we go to this other, so I am going to show you how we could use or put this in a panel like this one. So basically we will do it in this way, in a way that we use a bit larger screws, okay, and basically what we will do is to put this one in this way. We will put the knob, that I recommend you to use this kind of knobs that I will link you in the description, also the encoder and everything, and or this one, right? And basically we put the nut in the switch, and that will be all. So basically, as I said, it's really easy to integrate. Also, one thing that I will recommend you, once you assemble it, if you put here in this connector and on the other a bit of epoxy, that in a way that this PCB keep in position in a better way, which more suitable, is not needed, but that's it, it's better. So basically I would say that's all for the presentation on this controller. Everything, it will be, as said, uploaded into the repository. I am working currently in the software because there are some bugs that they need to be resolved, but in the next video I will show you how this works, at least the software that I have been working on, and a bit more information regarding probably how to connect everything. And yeah, I am thinking about produce a small batch of these PCBs. So basically you can subscribe to the channel to keep you posted, also on Instagram, because I will post there everything that you will find it in the screen. I will put you there, and I will work in the next videos, but for the moment you will be already entertained checking the manual. Please send me recommendations, something that you find, let me know, because I will keep everything updated. And just to let you know that this is the second iteration. because this was the first one that it needs some corrections, and as you can see, the potentiometer is smaller in order to be able to fit the two outputs, because here it was only one auxiliary input. And yeah, some minor improvements that they were implemented in this new version that I consider, let's say, the official one. So I hope you enjoyed this video. As said, follow for more. And if you are interested in this, you can send me a private message in Instagram, feel free. And any doubt, don't hesitate to ask me. So thank you everyone, I hope you enjoy, and see you in the next one.